5.4, page 274, try it yourself 3. The diameters of fully grown white oak trees are normally distributed with a mean of 3.5 feet and a standard deviation of 0.2 feet. Random samples of size 16 are drawn from this population, and the mean of each sample is determined. Find the mean and standard error of the mean of sampling distribution, then sketch a graph of the sampling distribution. So what we're looking for is we're looking for the mu sub x bar and the sigma sub x bar. So what we're given, first, let's start with that, is the mean, which is 3.5 feet, and the standard deviation, 0.2 feet, and then we've got a sample size, Rn, which is 16. And so we're trying to find our mu sub x bar first, which is just the same thing as the mean. And so that's just going to be 3.5. Next, we're going to find our sigma sub x bar. And the formula for sigma sub x bar is sigma, the standard deviation, divided by the square root of the sample size, which is n. So in this case, it's going to be our standard deviation, 0.2, divided by the square root of 16. And so that'll give us 0.05. And the next thing we're going to do is we're going to draw a sketch. So first, we need to put on here our mean. So our mean here is 3.5, and then we're going to do our one standard deviation. And so we're just going to do 3.5 plus 0.05, which would be 3.55, two standard deviations. And so this is just mu sub x bar plus sigma sub x bar. And then it's going to be mu sub x bar plus 2 sigma plus 3 sigma. So you're just going to add another 0.05, so that would give us 3.60. And then the third standard deviation would be 3.65. And in the same way, we're going to subtract. So if you subtract 0.05, we get 3.45. Subtract another 0.05, we get 3.40. And subtract another one would give us 3.35. So I think you get the idea there of how to sketch it with the mean and the standard deviation. Page 276, section 5.4, try it yourself 4. You randomly select 100 drivers aged 15 to 19. What is the probability that the mean time they spend driving each day is between 24.7 and 25.5 minutes? Use the mean as 25 and the standard deviation is 1.5 minutes. So first we're given the mean is 25 and the standard deviation is 1.5. And then we've also got the sample size here, which is 100. So first we need to find our mu sub x bar, which is just the same as the mu, which is just going to be 25 there. And then our sigma sub x bar, which is the standard deviation divided by the square root of n. In this case, it's going to be 1.5 divided by the square root of 100, which will give us 0.15. And so now we're asked to find the probability that it is between 24.7, and this is the x bar, the mean, and 25.5. So for the z, we're going to try to find the probability that the z is between those. So we're going to take our 24.7 minus our 25, x bar minus mu sub x bar, which is our 25, divided by the sigma sub x bar, which is 0.15. is less than z is less than, now we've got the 25.5 minus the 25 divided by the 0.15. Calculate those, make sure you press enter after you subtract them before you divide. Will be between -2 and 3.33. So on our curve, the -2 is on the left of 0. Here's our 0. There's our -2. And then the positive is the 3.33. So we're trying to find the area from this -2 all the way up to the 3.33. So we're going to find these two areas, the area for the -2 to 0 and then the 0.33. So we're going to look up the 2, which is the same as -2. I use the alternative method here. So the 2 is just 2.00, which is 0.4772. So this is 0.4772. And then the 3.33, let's go down to 3.3, and then go over to 3 to be 0.4996. We're going to add those together, the 0.4772 and the 0.4996, and that'll give us a probability of 0.9768. And so the probability of it being between those two is 0.9768. Get my box there.